Hello viewers, welcome to our second part of the topic further logarithms. It's math and I'm your teacher Jeff. So yesterday I explained 3 laws of logarithms and their application as far as expressions are concerned. I also mentioned that all my explanation will be based on expressions first, but then later on in the topic we look at the same laws as they're supposed to be applied in equations. So I left it at the third law, just a reminder, which was log a base x equals to b, which was the same as b log a then base x. I tried to explain how this is supposed to be used, especially when it comes to simplifying fractions where division is involved. We did some few examples, and I think you can remember that. So today, we have to proceed by me now explaining the next law, which is the fourth law, and it is the law which involves, first, before I talk about the law, I will take you back to your Form 2 indices. In indices, you know that if you have a number 2 raised to like 1, the answer is 2. 3 raised to 1, the answer is 3. 5 raised to 1, the answer is 5. So any number raised to 1 gives you an answer which is the same value. Okay, in the first part of this topic, I explained how to change indices into logs. And I said that if you have such a statement, then this becomes log this log 2, then this becomes the base, then the log's answer is the power, which is 1. The same thing for this. This should be log 3 base 3 equals to 1. The next should be log 5 base 5 equals to 1. So if you look at this carefully, you notice that the log and the base are actually the same, which takes us to the next law. And that law has to do with the logarithm of the base. And it states that log a base a equals to 1, which means anytime a log is equivalent to the base, then the answer is supposed to be 1. So main thing is first get used to the law. Once you know the law, then think of how you can use the law in application to do with questions now. In the previous topic, I had mentioned something to do with the common logs. And my common logs were like log 10. There's something else I also mentioned. I said that if you have a log with a base not shown, then it means that the base is an obvious base, which is a base 10. Then I said in that topic, log 10 is a common log and it's equivalent to 1. Maybe this is why. I had promised to explain why. Then from this we can see why it was 1. Because log 10, it means there is a base 10 here. And the answer should be log a base a equals to 1. I said log 100 is equivalent to 2. Think about it, log 100. With the base I'm explaining, the base is 10 here. Consider the third law, which was log a base x raised to a power. If I raise this or write this 100 in terms of 10, then it gives me log 10 squared base 10, which is equals to 2 log 10 base 10, which is equals to 2. And that's why I explained this. I say that anytime you see log 100, it's the same as 10. Same applies to 1,000, because 1,000 is the same as 10 raised to 3. 10,000, 10 raised to 4. So it will be log 10,000 base 10 equals to 4. Now, the application of this law, as far as the questions in exams are concerned, in expressions, there is always simplifying values. When you simplify, you try to write a value in the simplest form. And if it's logs, then it means we have to use the laws of logs we are explaining to do that. So far we have done 3 logs. This is the fourth. Then think of a question like, now I want to do a question where I'm applying the law log a base a equals to 1. Think of this question, a question like 3 log 125 base 5. Now that, I will not use this first. Let me pick another different example first. Think of a question like 2 log 5 minus 3 log 2 plus log 32. Okay, we already did the first law, the second law, and the third. So you look at this, you can see minus means the second law can be applied somewhere on that. Here there's a minus, second law, there's a plus, first law, if you follow the first lesson that we had. Then if I'm simplifying this, at start, it looks like it only requires the first 2 laws. And maybe, so if I simplify, and when you have such a number where there's a coefficient, it's always a rule that take it back. So this statement should read log 25 minus, again for this it will be log 8, because 2 raised to 3 is the same as 8, then plus log 32. Okay, just using the first and the second law, this as a single log should be the same as log 25 over 8, then times 32. That, remember, if there is no base, it means the base is a common base and the base is 10. Always have that in mind. So that said, if you worked out this, 25 divided by 8 times 10 times 32 should give you an overall answer, which is log 100. But then, log 100, you know the base is 10. If you leave your answer this way, it's not simplified fully. So you have to make sure that any answer you write is in its simplest form. So because of that, we have to think about, if this is 100, can this 100 be written in terms of 10? Yes. 100 is the same as 10 squared. So this would be log 10 squared base 10, which is 2 log 10 base 10. But according to this law, when a number, a log and its base are the same, then it's 1. So the answer is 2 times 1, which is equals to 2. So I hope you get that. Now, next example is for a question 3 log 125. Now I'm using a different base, not 10. Then plus 5 log the square root of 81 base 3. Now, according to the laws of logs, you can only consider adding logs if the bases are the same. But now, look at these bases. The bases are different. When you're working out questions which are in such a form, what it simply means is try to think of how to work this on its own, this on its own, get the 2 answers, then now add them. So for this question, I can see a 5 here. The first thing to think is there any way I can write 125 in terms of 5? Yes. 125 is the same as 5 raised to 3. So this statement here would be 3 log 5 raised to 3 base 5. Plus, how about this? First, I start with the square root of 81. The statement should be 5 log 81 square root is the same as 9, then raised to 3. Again, according to the third law, anytime there is a power, you have to write it as a coefficient. So which means this 3 as a coefficient will be 3 times 3, which is equals to 9 log 5 base 5 plus this 9. Can 9 be written in terms of 3? Yes. So this statement here is the same as 5 log 3 squared base 3. And again, just like I did it there, I'll have to do the same thing here. And for this question, it's 9 log 5 base 5 is the same as 1. These 2 to the other side will be 2 times 5, which is 10, then log 3 base 3. Again, 9 times 1, it's 9. Then log 3 base 3 is the same as 1. So this statement here becomes 10. Then if you add these 2 values, the final answer is 19. So you look at that, we're using this law where you check anytime the base and the log are the same, the answer should be 1. And it's a very important thing, both in expressions and equations. Another example of the same. Now let me involve different type of an example. The question is, given that, I will not write the whole question because of time. So some parts I'll read, I'll write what is necessary. Given that log x base a equals to 1.4. Given that log x base a equals to 1.4, find the value of the following. So again, I'm trying to put this law and any other law that I've explained in context here. So you just try to use what is possible. Anything possible that you can actually use, you try use that. So next is, first question I'm supposed to simplify is log x cubed, then base a. So look at that. Anytime the powers, think of the third law. You have to always write these values as coefficients. That's how to simplify these things. So this statement can be written as 3 log x base a. But according to this statement, log x base a is equivalent to 1.4. So instead of this, I change that to 1.4. Then I'll multiply this. If you multiply this, 4 times 3, 12, carry 1. 3 times 1, 3 plus 1, 4. So the answer is 4.2. That's for my first example. The second one, B. I'm still using the same. Given that log x base a equals to 1.4, I'm solving the following. The next one is log the square root of x base a. So the base is a, just like that. So first I have to simplify this. Square root of a number is like that number raised to a half. So this statement is the same as x raised to a half, then base a. Using the third law, this is supposed to be written as a half log x base a. But x base a is the same as, x base a is the same as 1.4. So it's a half times 1.4, which would give you whichever value that you get in that case. And in this case, it's supposed to be 2.8. Okay, so that's it. That's all about simplification. Now, the next thing we're supposed to do is move to the next law, which is logarithm of unit. Again, according to your indices, a number like 3 raised to 0 gives you a value 1. 4 raised to 0, 1. 5 raised to 0, 1. X raised to 0, meaning any number raised to 0, the answer is equivalent to 1. I think about the same in terms of logs, because in the previous chapter, we learned how to change indices into logs. So this statement as logs should be log 1 base 3 equals to 0. The next one, log 1 base 4 equals to 0. Next one, log 1 base 5 equals to 0. Next one, log 1 base x equals to 0. Conclusion from this is any log 1 to any base, the answer should always be 0. Log 1 to any base should always be 0. So the law is mostly applied in equations maybe, but sometimes you can use the same concept in simplifying expressions, whereby I simplified an expression and the final answer was log 1. Then in that case, you don't actually write log 1. You're supposed to write the final answer as a 0. For example, I'll use one example on expressions for this. Just one example. Then we move on. So any other explanation on this will be in equations. So consider that. So before I use the example, remember the law. The law is log 1 base anything. So it can be any value. The answer should always be 0. So anytime you have log 1, remember to write 0. Or in logs, anytime you have a 0, you can write 1 to the base of anything. Okay, the example I use, simplify log 30 plus log a half minus log 15. I'm supposed to simplify this. So simplification of this, you see, it's all about the first, the second law. But now, in the process, as you keep doing the question, something else can come in. Some other law might come in. First law, second law, because I see addition, subtraction. Maybe something else comes in, and that's what you're watching. The main thing is try simplify your expression as farthest as possible. So the answer for this should be, this as a single log is a log 30 times a half, then divide by 15. And this clearly is 30 divided times a half is the same as 15 divided by 15, which is equals to log 1. So if you write your answer as log 1, you're actually wrong. So the correct answer is supposed to be 0, because as I already explained, log 1 to any base equals to 0. I've also said that some more explanation or application of this is normally in equations, what I am now almost starting. So now I've explained around how many laws? 5 laws, I think, to do with the questions relating to expressions. The law of addition, subtraction, power, logarithm of unit, alafu, the logarithm of a base. So those 5 laws. I've explained 5 laws, showed how you can use them in expressions. They're not the only laws. I'm still explaining some other laws, but the other laws that are remaining will have to do with the equations. So I'm about to start logarithmic equations. That's solution of logarithmic equations. And now, the difference between an equation and the expression is, for an equation, you solve to find the value of unknown. For expressions, there is no equal sign. So you only simplify by either factorizing or expanding. To expand, maybe, if it's algebra, that is. Expanding is removing brackets. Factorizing is bringing in brackets. Even though, for expressions in this case, there aren't fractions as such. I mean, so there is no questions to do with the brackets as such. So this kind of simplifying is different. But just know that for equations, you solve to find the value of the unknown. For expressions, you simplify a value in its simplest form. Okay. So now, next is equations. And if I talk about equations, then it means has to be I have something that has an equal sign with a unknown value in it, which I'm supposed to solve. So equations are supposed to be solved using the first laws, the laws that I've explained, maybe, and there might be some other laws that I'll explain later on. For example, think about this. Given that log 3x minus 1 minus equals to log x plus 13 minus log 2. The question is obvious. So the obvious question that will be asked from this is find the value of x. There is an equal sign, there is an unknown, so you're supposed to find the value of x. Solving logarithmic equations, it's a very simple thing and very common in exams. So this is something that you as a student should take serious. So I'll use a few examples which will have some slight difference in the setting of the questions, which I need you listen to very well so that you don't make mistakes. So the first example is kind of direct, very direct, and it is, if you want to solve a logarithmic equation, the rules are, first of all, make sure that every number in the equation is in form of logs. So if I look at this, every term, this is a log, this is a log, that's a log. So that first part is okay. The next part is, after ensuring that there are logs everywhere with the same base, check on some other thing like, are there coefficients? If there are coefficients, remove coefficients. Remember law 3, coefficients, if I have a number like a log b, this is what I'm calling a coefficient. To remove it, take it to the other side so it becomes log b raised to a. So there is that. So for this question here, I have log x, 3x minus 1, then that. I don't have coefficients, I have logs everywhere. The question is ready to be done. Now when you're doing the question, just follow the other laws of logs that I explained. So on the right, there's only one value. So I'll still write log 3x minus 1. But on the left, there is only one value. And on the right, there are two values of logs separated by a negative. Remember the second law. So it means this written as a single law will be log into brackets 3x plus 13 divided by 2. Now, once you have one log on the left, one log on the right, get rid of the logs, then work out the values. So this leaves you with the 3x minus 1 equals to x plus 13 over 2. This is a normal algebraic equation, so solve it to get 2 into 3x minus 1 equals to x plus 13. So this should be 6x minus 2 equals to x plus 13, which should be, collecting like terms, 6x minus x equals to 13 plus 2. 6x minus x, 5x equals to 15. So the value of x should be 3. I have solved that. So when you're solving a logarithmic equation, I say that first of all, make sure that every term in the logs equation is in the form of logs. Number 2, in any place where there are coefficients, remove the coefficients. Then once you have done that, go back to the normal laws of logs. When you see minus, divide. When you see add, you multiply. Then come up with this, then eventually you solve. I think it's clear. Okay, next example. I said I'd use few examples with some slight differences in them, which I want you to note so that you don't make a mistake. Next is a third log 125 minus log x squared equals to 125. So according to the rules and the first question I did, I said that first, not 125, it's supposed to be log 125. So according to the rules, I said that rule number 1, make sure that all the terms have logs on them, which is okay. Number 2 was, any place there is a coefficient, get rid of the coefficient. I can see a coefficient here. So that's the next thing that I should do. So how? The third law, this has to go back. So it will be log 125 raised to a third minus log x squared equals to log 125. Then if I simplify this, it means the cube root of 125, which is the same as 5. So this log 5 minus log x squared equals to log 125. Then I don't have coefficients, I have logs in all the terms involved. Next is solve, simplify by writing values on every side as a single log. Minus means divide, so this should be log 5 over x squared equals to log 125. Okay, next. Once you have only two terms, one on the right, the other one on the left, get rid of the logs, then you'll have 5 x squared equals to 125, which should be 5, 125x, multiplying x squared on both sides, which leaves me with x squared equals to 5 over 125, x squared equals to 1 over 25. Then the value of x for this question will be square root on both sides, which is plus or minus 1 over 5. Okay, next example. So the new thing I brought in is, for this question, there was a coefficient, unlike the first one. So the third example, consider the third example. The third example is a log (10x plus 5) minus log x minus 4 equals to 2. Same process. First of all, I'll check, do I have logs in all the terms? I have a log, no log. Then if there is no logs, next is I have to make sure that I introduce logs to this value here. Doing that, the log that you introduce here depends on the base of the other logs. So this was base 10, base 10. So it means for this to be an equation, it can only work out if the bases are the same, and the base should be 10. Then I'll add log 10 base 10. Now, remember what I said, logarithm of the base. Logarithm of the base was when a log and the base are the same, the answer is 1. So me writing here 10 log 10 base 10 does not change this meaning. If you simplify this, then the answer will be 2. So the only thing I did is I wrote 2, but in terms of logs, by introducing logs. If the base was 6, then I could have written log 6 base 6. Because log 6 base 6 is the same as 1, it doesn't change this statement. So now, this log was base 10, and base 10. So me doing that, it's okay. If it was 3, then this should be log 3 base 3. I hope you got that. So now, at least I have logs to all the values, all the terms. Now, next thing is check the next thing, which is the coefficients. Do you have any coefficient? Because of this introduction of logs here, makes this a coefficient. So I have to get rid of this, which would be log 10x plus 5 minus log x minus 4 equals to 2 on the other side, leaves you with a log 100. Okay, now, I have logs on all the terms. I don't have coefficients. So the next thing is just do the operation using the other laws, which would be minus I divide. So it would be, this as a single log would be 10x plus 5 x minus 4 equals to log 100. Okay, next. Then I have a single log. Get rid of logs, work out the algebraic values, which would be 10x plus 5 x minus 4 equals to 100. So next part is multiply on both sides by x minus 4, 10x plus 5 equals to 100 into x minus 4, which is 10x plus 5 equals to 100x minus 400. Collecting like terms, 400 on this side, 10 on the other side, I'll have 5 plus 400 equals to 100x minus 10x. Okay, 100x minus 10x is the same as 90x. And this added gives you 405. So when you divide this, the answer should be 4.5. That is it. The next example. If you look at these questions, you'll notice there is a slight difference in the examples I'm using. So anytime you are reviewing it, try to check on that so that you don't make mistakes, because anytime they ask a question, there should be something that you should be able to see and relates to some of these things I'm explaining here. Okay, next example is log x plus 5 equals to log 4 minus log x plus 2. Log x plus 5 equals to log 4 minus log x plus 2. Okay, now, I'm supposed to get the value of x just like in a normal case. Somebody might think this question is the same as maybe the first example I explained, but listen carefully because there is something that might be different that I need to explain as far as this question is concerned. So now, there is logs everywhere, there is no coefficients. So it's simply solving. Now, if you're working out this, make sure that you have one term on the left, one term on the right. On the left, I'll have x plus 5, like I've already explained. On the right, there's division, so this should be log 4x plus 2. Okay, then x plus 5 equals to 4 over x plus 2. Now, if you cross multiply, you'll have x plus 5, x plus 2 equals to 4. Ends up to be quadratic. Maybe because I have two terms, when multiplied, it will be quadratic anyway. So it's x into x plus 2 plus 5 into x plus 2 equals to 4. So this should be x squared 2x plus 5x plus 10 equals to 4. Collecting like terms, it will be x squared plus 7x. This on this side should be plus 6 equals to 0. Okay, so I have x squared plus 7x plus 6 equals to 0. Using either factorization, the quadratic formula, whichever method you use to solve this. In my case, let me use the quadratic formula. Minus b plus or minus b squared minus 4ac over 2a. The negative of b is negative 7. Square root of 7 squared minus 4. A is 1, c is 6. Then over 2a, 2 times 1 is 2. So this should be negative 7 plus or minus 49 minus 24. Square root of 25, then divide by 2. So it's 7 plus or minus 5 over 2. Then the values of x should be, first x would be negative 7 plus 5, which is negative 2. Divide by 2, negative 1. Or negative 7, negative 5, that's negative 12. Divide by 2, negative 6. So this is what I wanted to explain. My explanation is in the answers that I get. Now sometimes when you're solving a logarithmic equation, whereby it ends up being quadratic, you may notice that you will get two answers. In some cases, both the answers can be correct. In some cases, one of the answers may not be correct. So what you should notice is, as far as logs are concerned, you can't have something like log negative, then a value. You can't have log negative 5, log negative 3, and so on. So because of that, when you get these two answers as a good student, try and replace the values in the possible places where there is x in the equation, so that if there is any place you'll end up getting a negative answer, then whichever value you're substituting is not supposed to be considered. Okay, for example, if I consider negative 1, put negative 1 here, my overall answer will be 4. That's okay. I put negative 1 here, my overall answer will be 1. That's okay. So it means this value is actually correct. How about negative 6? I put negative 6 here, then I'll have negative 6 plus 5, which is negative 1. So obviously, negative 1, I can't have log negative 1. So just like I've explained, then it means that this value should not be considered. So the final answer you should write should be the value of x is just 1. That's how it should be. So I hope you got that. My explanation was, for this example, it was majorly based on the type of answers you get. Anytime you're solving a logarithmic equation and it's quadratic, ends up being two answers, don't just think the answers may be correct. Maybe one of them can be, both of them can be correct. The best thing to do is try and simplify, substitute those values and see what you get. Now, one more example for today's lesson. My next example is log x minus 2 plus log x minus 6 minus log 5, then equals to 0. The reason I'm explaining this example is because of the 0. We've talked of 0 already. I said that 0 is the same as log 1 base anything. So, and according to the rules of equations, I say that anytime you're working a logarithmic equation, make sure that you have logs in every value that you have there, every term. So there is logs, 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 no logs. Then this is what you do. At this point, you introduce log 1. So once you do that, then you have that normal equation. You can follow the process I explained to solve and get the answer. But now, there is a second option. If at all you don't want to use log 1, because maybe some people say, replacing this with log 1 gives you so many numbers, which can be actually hectic to solve. Any equation that has equals to 0, in most cases, there will be one part of this part of logs that will be negative. So for me, I will say you can use that first way, or you can decide to take like this value, the negative one on the other side, just to make the equation simplified, not adding many logs in it. So then you'll end up having x minus 2 plus log x minus 6 equals to log 5. And I think this is that normal equation we already explained. There is logs everywhere, no coefficients. So you simply write this as a single log, x minus 2 over x minus 6, then equals to log, sorry, it was plus. So if it's plus, it means I have to multiply the respective values. X minus 6, then equals to log 5. So then with that, get rid of logs, you'll have x minus 2, x minus 6 equals to 5. Then now solve this. Expand, have a quadratic equation, solve. So obviously it's quadratic. I expect to get 2 answers. Once you get the answers, remember to substitute the values to know whether the 2 values are correct or one of them is wrong. Because it's not all the time that when working out this, the answers you get will all be correct. So you just work out, check the values to know which one might be correct or wrong. So this question brings us to the second part of further logarithm. There is still part 3, which involves further application of questions to do with the logarithms. Thank you for listening.